So this is part 2 of 3-2. We're going to skip a couple. We're going to go straight to 9. All right, so what can you tell me about this graph before you even get like heavy into the work? Falls left, rises right. The y-intercept is 0, 7. Is it factorable? No. So how am I going to find the roots? Possibles. So my possibles are plus and minus 1 and 7. Now let's pretend we don't have the calculator. We would do negative 1. 1, 6, 12, 7. Bring down the 1. So 1 is one of the zeros. Negative 1, sorry. Then I'm going to take what's left here, which is not factorable, which means how do I solve for it? Quadratic. So A is 1, B is 5, C is 7. Negative B plus and minus the square root of B squared minus 4 times A times C all over 2 times A. So because there's a negative under the root, what's this tell you? There's no other 0 that's going to cross through. So this is one of those weird graphs. So this kind of question, if it was on the part with the calculator, you're not going to graph it because those are imaginary roots. It may just ask you for the zeros. It may ask you for the x-intercept. So if it was x-intercept, it's just negative 1, 0. If it asks you for all the zeros, it'd be negative 1, negative 5 minus I root 3 and 2 over 2, and negative 5 plus I root 3 over 2. You can leave that as plus or minus if it's an open-ended question. That's fine. If it was on the calculator portion and you did have to graph it, then you would just use the graph to kind of help you out. So I know that it would have negative 1, 0 as the only time it crosses the x-axis. And I know it's 0, 7. And I know it falls left and it rises right. So it's going to do some sort of a weird shape in between here. If I wanted to know exactly what it was, I have to plug in a point. So if I wanted to plug in negative 1/2, the good news is you have a calculator. If that's that kind of question. Like if it's a graph and question like that, you're going to have a calculator. So that should help. But this is negative 1/8 plus 6 times 1/4 minus 6 plus 7. This would be 3/2 plus 1. And then I can give them all a like denominator. Times 4. 1, 8, 8. And this is 11, 19 over 8. Wait, this should be 8, sorry. So this is 2 and 3/8. So I know that here it's like around there, which is kind of accurate where we put it. So this is great practice for one that is with a graph and calculator without the graph. So you'd have to do the possibles to either find one using this way and then take the rest and use quadratic to find all the zeros, okay? Now go to 12. What can you tell me about this graph right off the bat? Falls left, rises right. Is not factorable. And it's not quadratic. Good. Y-intercept is 0, 7. So I have to do the possibles. Here's where it gets a little bit tricky. This is 1 and 3. This is 1 and 7. So the possibles are the last over the first. So plus and minus 1 over 1, which is 1, 7 over 1, which is 7, and then they both have to go over 3, 1 over 3, and 7 over 3. I'm going to tell you right now the whole numbers are not going to work, and that's how it's going to look on your test. So you're going to have to, this is why you're getting a graphing utility. You're going to then get out your graphing utility, and you're going to graph it. Yep. No, they could be fractions. We just haven't had a lot where there's nothing where there's something in front of the first term, but it is possible. Yeah. Minus 13. Actually, I plugged in my equation, and then I'm gonna hit graph. Do you see it cross through any whole numbers? No. Guess what? That's what's gonna happen on your test. Okay, which means I can rule out 1 and 7, which means I have to test for the other ones. So what does 1/3 look like in a calculator? 0.333333333, right? If I didn't know what 7 over 3 would look like in a calculator, I would type in 7 divided by 3, because 1, you're not going to see it in the table. Table's only going to give you whole numbers, which means we have to use that trace feature. I have to figure out which of these zeros is going to line up. So I'm going to go to my y equals, I'm going to graph it. I'm going to go to second trace. I'm going to go to 0. I'm going to start with the one on the left. Go left of it. Go right of it. Let it guess. And it's negative 1.316, so on and so forth. You're not even going to round it. You want to find the one that matches your possibles. So I go second, trace, 0. Go to the next one. Left of it, right of it, and there's my 0.3 repeated. So that means the possible one that I already found on my graph is what? 1/3. So 1/3 is one of my zeros. There will be one that's identifiable, like a fraction, you could figure it out, but it's not going to be something like 0.5. It's not going to terminate, okay? It's not going to be a whole number. So you got to work with what you've got. You've got to build your bank of possibles and then figure out from there which one's going to match one of your zeros. Does that make sense?
So if the question's like, what are the possible zeros, you would put all the other ones that...
The possibles, you're going to list it just like this.
What about the first point on the graph?
Then that's one of your zeros. So now I'm done with my graphing calculator for now, because the rest of the work I got to do to keep it exact. So now I know 1/3 works. How do I find the other ones? Because they're not going to be from your possible bank. You got to put 1/3 on the outside of your synthetic division bar, and you got to work it out. So 1/3 is going to go on the outside. And then I list all my coefficients. 3, negative 13, negative 17, 7. Bring down the 3. What's 1/3 times 3? 1, negative 12. What's 1/3 times negative 12? Negative 4. What's 1/3 times negative 21? Negative 7. So if you've done that correctly, 1, you'll end up with whole numbers because they're always going to be divisible. 2, the remainder should be 0. Now I've got 3x squared minus 12x minus 21. I can try to factor it, but I'm going to tell you right now it's not going to be factorable. Otherwise, I would have been able to find it from my rational zeros at the beginning. I can divide everything by, so I can set this equal to 0. I can divide everything by 3, make my life a little bit easier. And then what? Quadratic formula. So A is 1, B is negative 4, C is negative 7. 4 plus and minus the square root of negative 4 squared minus 4 times A times C all over 2 times A. This is 2 and 22, which is 2 and 11. So 2 square root 11 over 2 And I get 2 plus and minus square root 11. So my zeros are 1/3, 2 minus square root 11, and 2 plus square root 11. You cannot just trace and get the decimals there. So when you list these as answers on your test, they have to be exact. You're using your calculator just to find the one that works, but then when you list them, they have to be exact. I cannot list them as like 1.3, negative 1.3. It has to be the exact value. So you're finding one that's going to match one of your possibles, and there's only going to be one that matches because the rest you're going to have to use the quadratic. Okay? None of those things occurred more than once, which means multiplicities, all just one, right? So it's going to cross through each one of those points. Now, the 1/3 is not that bad to graph. I'm going to just plot the 1/3. I'm also going to plot the 0, 7 because my y-intercept. Now, 2 minus square root 11, I have to approximate kind of like what we did with the parabolas. Root 11 is in between what other perfect squares? Good, square root 9 and square root 16, which means it's in between 3 and 4. You could pick halfway, doesn't matter. You're not going to get that specific. Let's say it's 2 minus 3.5. That means that's negative 1.5, which is where I'm going to plot one of the points. And then 2 plus square root 11 would be like a 2 plus 3.5, which is 5.5, and that's where I'm going to plot the other point. Now, if you look back on your graphing utility, it crossed through about those points. It falls left, it rises right. I have the coordinate point in between the first two set. My y-intercept is good enough, but I need to figure out how low it goes in between here. So I'm going to plug in a point, like plug in 3, something in the middle there. And I'd get 3, 3 to the third, minus 13, 3 to the second, minus 17 times 3, plus 7. Good news is, again, you have the calculator for this. So let the calculator do the work there. That's 81 minus 117 minus 51 plus 7, and just plug it in. 81 minus 117 minus 51 plus 7, and I get negative 80. So it's going to ask you for the possibles, it's going to ask you for the actuals, it's going to ask you for the end behavior, and it's going to ask you for the additional points at the x-intercept and the y-intercept. And then any additional points you need like that, I would just come down here and I would plot 3, negative 80. Make my graph come down there and come back up again to cross through.
You don't have to choose 3, right? You do.
It could be anything in between there. Yeah.
And you said for, if it's like in between, like it's 4 and 5, you don't want to choose decimals, just
Yeah.
little curve.
Yeah. Yeah, that's fine. It can't go down that far in between 2 points like that. Yep.
I tried to do like the trace thing and I kept saying there was an error.
All right. All right. So what are your, first of all, tell me what you know about this graph. Falls left, rises right, and good. Y-intercept is 0, negative 3. It's not factorable, right? If I do my possibles, it's 1 and 5 and 1 and 3, which means my possibles are plus and minus 1 over 1, 3 over 1, and then 1 over 5 and 3 over 5. So if you wanted to like quick get those decimals and there's only 2 fractions there, maybe it's not the worst thing to check before you get into your graphing utility. But if you have a lot of fractions, I wouldn't start with that. Don't waste your time on it. But if you don't know them off the top of your head, that's 0.2 and this is what? 0.6. Good. So then when you go to your graph and you plot that on the graph, I should have typed it in already, 5x to the third plus 4x to the second plus 14x minus 3. It looks like this. So first of all, I know two things about this graph. One is there's only one real 0, which means only one of those possibles is going to work. The other thing is it's definitely not a whole number. So if I go to trace, second trace, and I go to the 0, and I go left of my 0, which is already there, and I go right of the 0, and then I bring it directly to the 0, it's at 0.2. And 0.2 is 1/5. If you have a lot of fractions, I wouldn't do it. But if you only have a couple, like I could do 1 divided by 5 real quick on my calculator and see what that decimal is, 3 divided by 5 real quick, so that when I go to look at it, I already know what I'm looking for. If there's a bunch of them, I wouldn't do it. But if there's only a couple, like 2, it's not so bad. So now I know that that 1/5 works. So the 1/5 is going to go on the outside. 5, 4, 14, and -3. Bring down the 5. 1/5 is 1. 5, 1/5 is 1 again. 15, 1/5 of 15 is 3, and that's 0. So again, if that's not 0, then you guessed wrong. That something's got to be wrong because that has to be 0 if that's one of the roots. This gets the x and this gets the x squared. So if 0 equals 5x squared plus 5x plus 15, I can start by doing what to make my life easier? Divide everything by 5. Only because it's equal to 0 can I do that. Now a is 1, b is 1, and c is 3. Negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. -1 plus and minus 1 minus 12. -1 plus and minus square root -11 over 2. So the fact that there's an I in that answer is consistent with what I found on my graph. There was no other real root. So my actual real root is 1/5. All roots would be 1/5, -1 minus I root 11 over 2, and -1 plus I root 11 over 2. And yes, if it's open-ended, you can leave it as plus and minus, okay? So this kind of question will stop there. It won't make you hand draw it, okay? If it did, you have the calculator to help you, but we know it passed through 1/5. We know it had a y-intercept at -3. I would have plotted something left of that, which is going to fall somewhere on the left, and then I would have something to the right of it to see how high it goes. So I would say really good practice problems for the for the graphing part are this one. 12, 13, and 12 are the best, like, for practice of that kind of stuff, okay?
For 13, we have to find one to the left, one to the right?
If you had to graph it, but you're not going to have to graph it. Yeah. So there's only one where you physically have to graph it on the paper.
So you can graph it when it has square roots, but you can't graph it when there's an I.
Correct. All right, so this is your review, okay? This is, I think I published it, right? Yeah. Okay, so it seems like it's been forever since we started this chapter. It's really been like 3 weeks, so it's not forever, but it feels like it's been a long time. So make sure you don't only focus on the graphing utility part. That part is 25 points. There's obviously 75 other points that come from the rest of the stuff. Okay, here's your review of division. So like I said, I don't think long division's on there unless a change happens in the next 24 hours. So I would practice just synthetic and long division just to be careful. Then you've got complete the square here. So remember, you're going to group it. You're going to bump the number to the outside, find that middle term, add it to both, factor it, go through the whole process of putting it into vertex form, which is the same thing as standard. Your axis of symmetry, so the vertex is obviously the HK. The axis of symmetry is x equals h. The x-intercept is when y is 0, and the y-intercept is when x is 0. It's not going to be one question that asks you all those parts. You're going to get a little bit here, a little bit here. So you might get a question like this that says, put it into standard form, and then you're done. You might get a question that says that, and it says, find the vertex. You might have a question that says, find the axis symmetry. So it's a little piece here or there. And then graphing is also part of it. 3 is already in standard form, right? So you can find your vertex, you can graph it. 4, you would either complete the square to put it in standard form, or to find the vertex, you could do negative b over 2a. So I would practice that on 4. I would practice the negative b over 2a to get the vertex and then plug it back in to get the y coordinate. That way you've practiced all 3 formats, putting it into standard because you're going to have to complete the square, pulling it from standard like number 3, and then 4 negative b over 2a to practice that vertex. 5 is the same, so I would say at that point you choose. Do you want to practice complete the square again, or do you want to practice negative b over 2a? Completely up to you. 6 is finding your x-intercept, your y-intercept. So this is just like what we started with yesterday. This would be no calculator. Find your zeros, find your multiplicity, and then graph it. 7, also no calculator, because you can test your possibles. 8, 11 and 12 are putting it into standard form. So remember that this is your h, your k, your x, and y. The question like this on your quiz, some of you switch the HK, the XY, so just be really careful. Remember the vertex has to be the HK, the point has to be the XY. The remainder theorem here is where you take whatever's inside the parentheses, put it to the outside, and then line up the constants. And then the remainder is your answer. Okay, so that would be for 13 and 14. Questions on expectations for review. So I would say do as much of this as you can tonight, if not all of it. And then tomorrow when you come in, actually I think I made this due tomorrow. So you're going to do all of it. And then tomorrow when you come in, we'll go through questions, like whatever it is that you need the most help with. If you're borrowing a calculator, make sure you are comfortable enough to use it on the test and not ask questions because I can't teach you how to use it that day. Hopefully by now you've gotten your own and you can practice with your own. Yeah, Sebastian.
You go to